All right, guys, this is going to be the transformations review, and I'm making this video just in case those of you finished with the retake for the solids test. So I'm going to try to go through this pretty quick. It's just a review. I think what I've got is another Jeopardy game that we are going to do on Monday, possibly Tuesday. And if we don't want to do the Jeopardy game, I can think of something else. But I think it went pretty well by the time everything was all said and done. So anyway, here's what we're going to do. Okay, I'm going to go through this pretty quick, and then I'm going to kind of just give you the information, and then expect you guys to work the problems, and then I'll show you the answers on those, and that's kind of how this is going to go. All right. So first one. Similar versus congruent, okay? Something is similar if it has the same shape and different size. That is, something similar is the same shape and different size. Something is congruent if it has the same shape and the same size, okay? Really, there are going to be, at least the way in which I taught you, there's three dilations that are going to be congruent and one that's similar. The one that is going to be similar is going to be the change in size, which would be a dilation. The ones that are going to be congruent are going to be the translation, the reflection, and the rotation. All right, those are the ones that are going to end up congruent because they will have the same size. So going back to translations, we call these slides. The rules is that if you are sliding to the left or the right, the x coordinate determines the horizontal distance, which is going to be the left or right. So the change in going left or right. The y coordinate is going to determine the vertical distance that you would be sliding. So vertical is going to be up or down. All right. So the rule is that if this is our pre-image x, y, then our new image would be either plus or minus whatever, however many units you are moving to the left or right, and then y would be plus or minus however many units you are moving up or down. Okay, so just kind of as an example, how does the rule x minus 2, y minus 4 change the pre-image? What's going to happen is that you will move left 2 units and down 4 units. Okay? So what I'd like for you guys to do is I'd like for you to pause the video now, and I would like for you to actually, before you do that, let me label some points here just so we know where we're going. So let's call this A, let's call this B, let's call this C, and then over here, this will be A, B, C, D. Okay, so go ahead and pause this video now and then translate both of these images. Okay, so hopefully you paused the video. If you didn't, no big deal. But translating 2 right, 3 down. So A prime would be 2 right, 3 down. That would be our new A prime. B prime is 2 right, 3 down. C prime is 2 right, 2 right, 3 down. So this is going to be our new image right there. Kind of looks off. It's not. It's not though. Must just be must just be my head. So this is A prime, this is B prime, and this is C prime. So that would be the first one. The second one, translate the rule using x plus 6 and y plus 5. So what that means is that we are going to be going right and up with all of these units. So A prime, right 6, 5 up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that would be A prime. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That would be B prime. C prime is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's C prime, and 1, 2, 3, 5, 6. 1, 2, 3, 4, 5. That would be D prime. All right. So label them. Make sure we've got those. This is A prime, B prime, C prime, and D prime. Okay. One thing that I forgot to do, since this is a translation, is it similar or is it congruent? It is going to be congruent. It will have the same shape and the same size, even though my first example doesn't look like it. It totally is. All right. Next, what we have is a dilation, which this is either going to be an enlargement or a reduction. So what you are going to do to dilate something is you're going to multiply each x and y coordinate by the scale factor, which we'll either call k, or sometimes it's called c. The way that I taught it was called k. So that's what you're going to do. If you have a scale factor that is greater than 1, that is going to be an enlargement. So you would have your figure getting bigger. If you have a scale factor that is less than 1, and technically it's between 0 and 1, if it goes negative, something different happens. But if you have something that's smaller than 1, it's going to be a reduction. Okay, so what I'd like for you to do is, again, pause this video and try your hand at these. A is going to be here. B, and this is for the pre-image. C is going to be right there. Over here, P, Q, and R, they're already labeled, so that's fine. All right, so pause this right now and then try your hand at these dilations. Okay, so since we are dilating and we have to multiply, what you would do is you are going to multiply 1/2 by our x coordinate and 1/2 by our y coordinate. So what I'm going to do is write A, B, and C for the pre-image. So A's point is at 2, 6. B's pre-image point is at 2, 2. C's pre-image point is at 6, 2. So after we multiply these by 1/2, we will get our primes. So A prime, if you multiply 2 and 6 by 1/2, you would get 1, 3. So that is where we would expect A prime to be. B prime, if you multiply 2 by 1/2, you'll get 1 and 1. So that would be B prime. And C prime, 6 and 2 again, it's going to be 3, 1 for C prime. Okay, so I'm just going to connect these right here. Maybe shouldn't have used purple, but that's okay. All right, so that's how we would do the first one. See, it's going to get smaller. It's going to be about half the size of the pre-image. On the second one, we're going to dilate by a scale factor of 3. So we're going to take 3 times our x and 3 times our y. So again, I'm going to write my pre-image coordinates. So P is at 1, 3. Q is at 3, 1. And R is at 1, 1. Okay? So when I multiply my pre-image all by 3, 1 times 3 is 3, 3 times 3 is 9. So 3, 9 is where P prime will be. 3 times 3 is 9. 1 times 3 is 3. So 9, 3 is where Q prime will be. And then 1 times 3 is just 3. So that is here. So we're going to end up being 3 times the size of our pre-image. Okay? And that's dilations. All right, that's dilation. So we're halfway done already. It does change size. I forgot to do this again. Since it's changing size, this is going to be similar. These guys are going to be similar. They're the same shape, but their size changes. All right, let's go to the back side. Next, what we have is a reflection. So for a reflection, if we are going across the y-axis, we're going to have our pre-image of x, y, and I'm going to actually set up the y-axis as well. The rule that we are going to use if we go across the y-axis is we are going to use the opposite of, or we're going to keep our x, but we'll use the opposite of y if we're going across the x-axis. So if you're going across the x-axis, the x stays the same. If you're going across the y-axis, the y will stay the same. Whoops. If you're going across the y-axis, the y will stay the same. All right? You could also just count, and I think that's what I'm going to do. I think some of you guys like using the rules, and that's fine, but you have to use the rules when you have ordered pairs. And I don't believe on these examples I do have ordered pairs, so I'm going to be trying to use my, the only ones that I'm going to use the rule on would be dilations. So I'm going to reflect these guys across their axes. So the x-axis is denoted by the x. So if there are points that kind of lie on opposite sides of whichever axis you are reflecting across, like for example, point D is above the x-axis. So after we reflect that, and E for that matter, both of those are going to be below our x-axis. So D is 3 units above that x-axis, so it should be 3 units below 1, 2, 3. 3 units below that x-axis. So that is where D prime would be located. E is 3 units above the x-axis, so it should also be 3 units below that x-axis. G and F are already below the x-axis, so when they are reflected, they're going to end up above the x-axis. So it looks like G is 1 below, so G prime should be 1 above the x-axis. Same with F. It is 1 below, so it should be 1 above the x-axis. I guess I didn't give you time to do these. Whoops, sorry about that. Trying to keep this somewhat short and sweet. And y'all know how I have a tendency to ramble. So that is what a reflection across the x-axis should look like. Now pause the video and try the y-axis. Before we do this, let me label. Sorry. So let's call this A, this is B, this is C, and this is D. Okay. Now, pause the video and reflect this across the y-axis. All right, so the y-axis is the vertical axis going up and down, so we would expect this thing to flip across left to right. So point A, actually this entire figure is all to the right of that y-axis. So everything on the right should be on the left. A is 1 unit away from that y-axis, that line of reflection. Let me do this. That indicates our line of reflection. So A is 1 unit away from that, so it should be 1 unit on the other side of that. That's going to be A prime. B is 1, 2, 3, 4, 5 units away. 1, 2, 3, 4, whoops. 1, 2, 3, 4, 5 units away. That is where B prime should be. C is 1, 2, 3, 4 units away. So C prime should be 4 units on the other side of that. And then D is 2 units away. So D prime should be here. And there we have it. Okay, that's going to be our reflection. They are the same size. They are the same shape. So these are congruent. All right. Last one that we have is rotation, which has most of the rules for it, and I think is the most complicated one. So you can use the rules if you would like. I don't know what I'm going to do here. I'm probably going to turn my paper, but you can use the rules on this if you would like. So our rules for a 180 degree clockwise rotation. And again, I'm going to set up my pre-image of X and Y. What's going to happen is if you're going 180 degrees, you're just using the opposite of whatever those ordered pairs are. If you are going 90 degrees clockwise, what happens is your X and your Y coordinates switch places. So Y will come first. And then since you're going 90 clockwise, you'll use the opposite of X. All right. This is also going to work for a 270 degree counter clockwise rotation. All right. Similarly, if we are going 90 degrees counterclockwise, what's going to end up happening is, again, X and Y will switch places, but we'll use the opposite of Y and just keep X as it was initially. It's just in the Y coordinates location. And this is also known as a 270 degree clockwise rotation. Okay. So I'd like for you guys to, I'm going to try to remember this. Actually, I would like for you guys to pause the video on this and try this, because I think rotations are going to be, I think they are the most difficult transformations that we're going to be doing. So go ahead and pause the video. These figures are already labeled. So there's that. So pause the video and yeah, try them. Okay, hopefully you tried them. If not, that was a weird, awkward pause. So what I'm going to do is I'm actually going to take and I know this is on the iPad, so it's not going to look like it, but I am actually taking my figures or my iPad and turning it 90-degree clockwise. If you need to know what direction that is, just watch the second hand on the clock. That's the way that I'm going to be turning it. 90 degrees is a quarter turn. So I'm going to turn it a quarter. A looks to be at the ordered pair 2, 2. And let me mark this just so you know where I'm talking about. Okay. So A is at the ordered pair, whoa. Hopefully that didn't go away. I accidentally locked it. Okay, looks like, okay, no harm, no foul. Got it. So A is at 2, 2. So when I turn it in the proper orientation here, I'm going to put a point at 2, 2 for A prime. All right. I'm going to do the same thing for B and C. So if I turn it to the right, hopefully don't lock the screen, B looks to be at 0.3, 5. So at 3, 5, I'm going to put B prime. Do one last one with C. C is at 1, 5, which is here. That's what we're going to call C prime. And I'm not a great artist here. I don't know, man. Just make a fish. Something like that. A little bit like that. A little bit like that. Okay, so that would be a rotation of 90-degree clockwise or 270 counter. There we go. For this 270-degree clockwise rotation, points are here. A is right here at looks to be 2, -2. B is -2, 5. C is at -4, +2. So that's the ones that we're going to be rotating here. 270-degree clockwise is the same as a 90-degree counterclockwise. So you either turn it 3 times to the right in a clockwise fashion or 1 time to the left in a counterclockwise fashion. Okay? So when you turn it, you get the correct orientation. My screen looks to be that A is at 2, 2. So let me upright it again. 2, 2 is right here. That would be A prime. Okay. When I rotate it 270 counter again, B is at -5, -2. So that would be here. I'm going to do it one last time for C. C is at -2, -4. Okay, so that's going to be C prime. Now, I think because as I was plotting these, I started to think, holy smokes, is this just a reflection? But it's not. I want to bring your attention to where these are located. So point A seems like it could be reflected with point A prime. The thing is, B, right, and then C, they're not really kind of where you would expect them to be for a rotation. So just keep that in mind. There is a difference between rotations and reflections. All right. Since this is the same shape and the same size, these guys are congruent. Okay. These guys are congruent. And that's it. All right. We've got some transformations, hopefully maybe a Jeopardy or activity or something to do next week or Monday if you're just getting around to it. I don't know. There will be a transformations retake. I'll get you guys your transformations test before we do the retake. I think I'm going to do it this weekend. And then there might be a Pythagorean theorem retake. I need to talk to the other math teachers to see what they are doing. But other than that, this is our transformations review.